All right, we are finding relative extrema. And before we get started here, I just want to talk about the symmetry of this graph, which I don't think I've mentioned in any of the other problems up to this one. And that is, this has rotational symmetry about the origin, which means that this function here is an odd function. Now, the one previously to this one was an even function. Remember, it was a big looking M and it was symmetric about the y-axis. Now, the reason I'm even bringing this up is the symmetry. Knowing the symmetry of the graph could actually save you a lot of time, and you won't have to do near as many calculations. For example, in this particular problem here, our critical number, well, let's let the cat out of the bag right now. It's a 4 and -4. But knowing that the critical number is 4, and because this function is an odd function, that means that there's going to be a critical number to the left of the origin here at -4. So we have a critical number at 4. That means there'll be a critical number to the left of the origin would be -4, and you would just have to find the minimum here, because then you would know that there must be a maximum occurring up here at -4. So really just finding one critical number and one min, you could find the critical number and the max over here to this side up here, and then from there you can tell where it's increasing and decreasing and so forth. But anyway, knowing the what an even and an odd function is could really save you some time. Okay, well, let's get started. Okay, so here's our function. Now we want to take the derivative, and so that means we're going to use the quotient rule. So we take the derivative of the numerator, which is -40, times the denominator minus the numerator times the derivative of the denominator, and the derivative of x squared plus 16 is just going to be 2x. And remember, it's all over the denominator squared. Now I went ahead and did the arithmetic out here, and hopefully you can get to this point right here without me having to go through all those steps. So anyway, and I went ahead and factored out a 40. Okay, so we set the derivative equal to 0, and then we want to find all the solutions to this equation here. And the first thing I'm going to do is take the numerator, set it equal to 0, and I end up getting x is plus or minus 4, which can easily be seen here. If we plug a 4 in, you get 16, and 16 minus 16 is 0. And if you plug -4 in, now remember, because it's a negative, you want to make sure you put that in parentheses, and that's -4 times -4, and the negatives cancel out. So a lot of people forget that, and they do -4 squared, which is going to be 4 squared is 16, and they just think it's -16, which is not the case. All right, then we're going to take the denominator and set it equal to 0. Okay, but there's no real solution to this equation here. There's not anything I can plug in, no real number I can plug in here to get this side to be 0. So our critical numbers are just plus or minus 4. Okay, so we got the graph drawn out, and I will go ahead and label -4 and +4, and we should take some test points. -5 is a good one, 0 and 5, and then we're going to plug the -5 into the derivative, 0 into the derivative, and 5 into the derivative. Now, of course, as you can see here, we know that there must be a maximum occurring here at -4 and a minimum occurring here. Let's go down and look at the math. So we plug -5 in, and we end up getting a positive number. So we know that the function is increasing at x equals -5. We plug 0 in, and did I say a negative number up here? We plug -5 in, we get a positive number, it's increasing. Okay. Plug 0 in, we get a negative number, so we know that the function is decreasing. Then we plug 5 in, and we get a positive number, so we know that the function is increasing. So now we want to find the actual point here. I plug -4 now back into the original function. We get a y value out of 5, and I plug 4 in, and we get a y value out of -5. So we can say that there's a maximum occurring at -4, 5, and a minimum is occurring at 4, 5, and that this function is increasing from -infinity up to -4, and then from 4 to infinity. Some people use a union symbol right here, union in these two sets, but I just used a comma. Okay.